All right, this is the last example, and then we have the discussion questions. So here, the natural log of x, you remember what natural log looks like. Natural log has an asymptote at 0. So we have a problem. We have essentially a discontinuity. Discontinuity at x equals 0. So again, we're just going to replace that 0 with t, right, so that we can sneak up on it with a limit when we're all done here. All right, so we get the natural log of x dx. All right, do you remember how to integrate natural log? Okay, remember we got to do this by integration by parts. So I'm going to let u equal the natural log of x. You've done this before. And du is equal to 1 over x dx. Okay, and then a dv is just going to be equal to 1 dv. Okay, and so that means v is equal to x. All right, so this is going to be u times v, so x natural log of x minus the integral of v du. So that's going to be x times 1 over x dx. Okay, and essentially we want to, this is going to be from t to 1, and then we could evaluate this from t to 1, but I'm going to wait until I've got it, the whole thing done, and then evaluate the whole thing. All right, because the one over the integral of this integral, then, because these x's will cancel out, is just basically the integral of 1 dx. So what we end up with is x natural log of x minus x evaluated from t to 1. All right, so let's do that. So if you plug in 1, we're going to get 1 times the natural log of 1 minus 1. Okay, and then we're going to plug in t. So we get minus, so this is going to be t natural log of t minus t. All right, so let's simplify that a little bit. Natural log of 1, that's just 0. So we end up with minus 1 minus t natural log of t plus t, just by distributing that minus sign. Okay, so let's see. We want now to do the limit. We want to take the limit as t goes to 0, because that's where our discontinuity was. And we want to take the limit of minus 1 minus t natural log of t plus t. Okay. All right. So now when we do that, we have minus 1 and then 0 times natural log of 0. That's a problem, right? So I'm just going to write that as minus the limit as t goes to 0 of t natural log of t, right? Because we get this indefinite form, because we can't, it's 0 times infinity, right? So we need to use L'Hopital's rule on that. So I'll hold that off to the side. And then the limit as t goes to 0 of t is just obviously 0. Okay. All right, so we don't have to worry about that. Now, let's just, on the side here, we got to do this limit. We got to do the limit as t goes to 0 of this t natural log of t, which I'm going to rewrite as the natural log of t over 1 over t. Okay, because then I get an infinity over infinity form, which I can apply L'Hopital's rule to, and then I get the limit as t approaches 0. And I'm just going to take the derivative of the numerator, which I get 1 over t, and the derivative of the denominator becomes minus 1 over t squared. And I can rearrange that, so that becomes the limit as t approaches 0, and it's 1 over t squared. I can put the t squared over on the top, so I'm going to make this minus t squared over t, and then of course one of these t's will cancel. So it's just essentially negative t, and the limit as t goes to 0 is just going to be 0. All right, so we found out that middle term is just 0. So that tells me that the integral from 0 to 1 of the natural log of x dx dx is equal to minus 1 minus 0 plus 0, which is just minus 1. And that's my answer. All right, so all we have left are discussion questions, so give those a try and I'll see you in class.